Hi, so today we'll be talking about the Caatinga region in Brazil, more specifically about the São Francisco River Basin. This is the outline of our presentation, and we'll start with a little bit of background. So the Caatinga biome is one of the main biomes of Brazil. It has an area of around 900,000 kilometers square and encompasses all of the states you can see in the slide. It's in the northeastern part of Brazil and it's considered a dry tropical climate. The reason it's a very dry tropical climate is because it has precipitations of around 500 to 700 millimeters on average, and it only rains on the rainy season. There's only 2 seasons. From February to May is the rainy season, and from June to January, the dry season. But it's a very important area also for biodiversity, since 30% of the vascular plants are endemic to that biome. But there's a lot of water deficit and erosion still in this biome. We'll be concentrating more specifically in the São Francisco River Basin, which is the only perennial river in the area. The Caatinga is home to around 18 million people, of whom agriculture and cattle ranching is the primary source of income. It is one of the places with most water, energy, and food insecurity, and it has other issues such as gender inequality. Even though the landscape has been modified, many families still rely on forest products for their homes. Before the arrival of the Europeans, the northeastern part of Brazil was inhabited by indigenous communities, mainly from the Tupi-Guarani family. After the arrival of the Europeans in the 1500s, more than 50% of the landscape has been changed to pasture or agriculture. Slash and burn is still a common practice in the area, but other food crops are grown near the São Francisco River that need more irrigation.
Although Brazil has made significant improvement on poverty reduction since the early 2000s, 2014 economic recession followed by 2016 housing crisis and 2020 pandemic put all these efforts under strain. Inequality is highest in rural areas of Caatinga, where it stands out with the largest concentration of African groups, indigenous groups, and female-headed households. The high inequality across class, gender, and race makes it difficult for these groups to own land. And it's even more difficult for them to secure their land because the land can be legally expropriated if not meeting social functions, which the law failed to define. As a result, 1% of the population owns more than 45% of the land. This long-lasting inequality especially affects small-scale agriculture. This type of agriculture accounts for 85% of the total agricultural production units, yet constantly being squeezed by large corporations, leading to the exploitation of rural labor. Without land and income, rural population rush into big cities in the south to work for these large corporations and form new rural areas. These new rural areas are short-lived, extractive, influenced by migration, and yet uninhabited, making it impossible to develop any sustainable agricultural systems. With the uneven distribution of land and labor, the region is still dealing with hunger despite Brazil being one of the biggest food production countries. Harvesting is centered in where the large corporations operate and mostly being exported. Not having enough funding or education blocks the way to develop agroforestry systems. In where the systems can be the most effective, it is the hardest to find necessary technology, knowledge, or even the basic infrastructure and labor.
The Caatinga region faces major challenges in relation to desertification, coexisting as a semi-arid region, and plant cover. The Caatinga is a dry tropical forest, and with that, desertification is a serious problem due to most of the region having shallow soils, a warm climate, and irregular rainfall. But this is worsened by deforestation, intensive livestock farming, and intensive and inadequate soil management practices. Another challenge that needs to be kept in mind is that Caatinga is affected by water shortages, which is intensified by domestic, industrial, and agricultural pollution. Rainfall is not only scarce but highly variable. From one year to the next, severe drought periods can last 3 to 5 years, every 2 to 3 decades, as well as in distribution variability along the year, usually concentrating within 3 to 5 months. Additionally, nutrient limitation also adds to this reduction. The sandy sedimentary soil in the Caatinga region has low nutrient availability. Lastly, the Caatinga region has suffered from vegetation and forest clearing due to cattle grazing and charcoal production, with the region plant cover declining by nearly 50% by 2009, which makes the area susceptible to soil erosion. Both the socioeconomics and environmental challenges that we brought up today demands effective action as one of the first steps in creating a more resilient, thriving, and socially just food system for all. The adoption of the agroforestry system can help restore and recover degraded areas by using strategies that integrate conservation with social and economic benefits. In the next few slides, we are going to recommend a couple of agroforestry systems for the Caatinga region.
The first agroforestry system we believe could help alleviate the issues of poverty, water, energy, and food insecurity, and land degradation is intercropping. First, by intercropping a mix of native fruit trees such as Cuiabera, Mandacaru, Umbu, Usaru, and Mangava, and non-native fruit trees like mango, tamarind, and guava, local communities will be able to improve their food insecurity by increasing the availability of nutritious foods and by increasing access to food by earning income, which will allow them to purchase additional staples like vegetables and starches. Second, by planting leguminous trees such as mesquite, farmers will be able to provide shade, fuel wood, green manure, and soil nutrients to their crops, while also having a source of fuel wood, thus alleviating soil degradation and energy insecurity. Third, prickly pear has been shown to restore soil integrity, and many farmers already use this species of cactus as fodder for livestock. The familiarity with this plant makes it easy to adopt and utilize. The next agroforestry system we recommend is a silvopastoral system with fruit trees and livestock such as cattle or goats. The same fruit trees used for intercropping can be grown in this context as well. These trees can also provide additional income, improve soil stability of grazing lands, provide shade for the soil and animals, and trees can provide forage while animals provide natural fertilizer, creating a mutually beneficial system.
The third agroforestry system we recommend is home gardens with presence of small animals, including poultry and pork. A home garden like this can produce grains, fruit, condiments, medicine, which can effectively reduce food insecurity and provide additional income that can promise household well-being. In this context, native fruit trees and fertilizer trees are planted together with vegetables near the farmhouse. Diversified vegetation can provide small animal feed as well. This makes more efficient use of labor and other resources. Another benefit of this option is that it can reduce domestic waste by reusing food waste, firewood ashes, and wastewater. The fourth recommendation is agroforestry for hillside restoration. This system employs goat and sheep droppings to plant native trees and forage shrubs. Given the drier conditions of the Caatinga regions, species must be adapted and resistant to longer, drier seasons. By growing resistant annual crops and fruit trees such as pigeon peas and soursop, fewer nutrients could be used better to achieve food production in basin areas. Fast-growing trees can be planted directly with seeds or cuttings at the bottom of the mounds left from digging out of the swales. The dugout part of the structures covered with animal manures and organic matter such as goat droppings could promote infiltration, soil fertility, seeding while avoiding soil erosion and reversing degradation. Lastly, we recommend a forage production agroforestry system. This is a system that generates food, income, while prioritizing livestock and maintaining biodiversity. In addition to livestock such as goats and sheep, which we know play an essential role in family farms, engineered species such as thistle are also planted in alternating rows, which helps to accumulate water and create more favorable microclimate. Exotic forage species are grown together with native forage species to feed the livestock, and the manure of these animals are brought back to the system as fertilizers, and it increases tree diversity and their ecological functions as well.
For all of these recommendations to be successful, there are two main barriers which need to be overcome. The first is education and extension. One of the main barriers is the lack of education. If people do not know how to grow fruit trees or plant a home garden, they cannot do it. More extension services and long-term support can help farmers successfully implement these practices. The second is supply availability. Currently, it is difficult to obtain seeds and other materials needed for planting trees. Cooperatives can help increase seed production while also giving women and other marginalized groups work opportunities outside the home. With greater access to knowledge and materials, these systems are more likely to be implemented.
We proposed 5 different agroforestry systems that could potentially help in the pathway towards creating a more sustainable and resilient Caatinga. Using any of the recommended agroforestry systems can help prevent desertification, as the agroforestry system can increase soil organic matter, available nutrients, and increase plant cover and productivity of the land. Trees can also provide erosion control, improve water infiltration, and provide land cover. Agroforestry allows farmers to combine the cultivation of multifunctional forests with other land uses, which generates and diversifies farmers' income. More diverse production with a variety of intercropping combinations allows the harvest to be spread throughout the year compared to one season in most farm systems. This also promotes food and energy security through the production of different crops, non-timber and timber products, and livestock. Agroforests can also protect water resources and help regulate the availability of water. Overall, by implementing agroforestry, Caatinga will move towards a more resilient, thriving, and socially just food system for the region. Small-scale farmers can become more resilient against climate change since they have a longer harvest season, can potentially buffer against extreme weather events, and provide food, water, and energy security.
All right, that is all we have. Thank you so much for listening. If you'd like to look again at our presentation and view our resources, please scan the QR code below.